Hi friends, welcome to my YouTube channel. Today we are going to see how to analyze a beam using direct element method. So this is the example we are going to solve. We have a formula for determining the stiffness matrix of the given beam. So K is equals to 2 EI by L, 2, 1 and 1 and 2. Okay, this is the stiffness matrix formula for a beam. See, whatever the beam that is given, we'll just first divide them into different elements, and we will now first calculate the fixed gain moments as we did in stiffness matrix. So here, see, the first element, whatever it is there, I'm just giving it as like notating it as a fixed beam over here, dividing it the whole ABCD span beam and dividing it like AB, BC and CD span. So for AB span, only one load is acting, that is the center one, 2 meters and 2 meters. So whenever we are calculating this resultant forces, we know MFAB is equals to, if it is having a central point load, it is simply WL by 8. This is the formula. I told you the left hand side would be negative and the right hand side one would be positive. Okay, next coming to BC span, it is having a UDL. Formula for that would be WL square by 12. BC1 would be negative and CB would be positive. Okay, next taking the span CD over here. So in this span, CD is negative and DC is positive. As it is carrying the central point load, it is simply WL by 8 will get the moment. Fixed gain moments. These are the fixed gain moments. First step is calculation of fixed gain moments. So the second step here is determining the stiffness matrix of the beam. For that, we'll consider the rotational degree of freedom over here. See, this is the given beam. We'll take the anti-clockwise one. Okay, we'll take the anti-clockwise one to be positive. That is, we are firstly defining the directions. Defining directions means we are taking anti-clockwise to be negative. Positive. Next, K for beams is 2EI by L, 2, 1 and 1, 2. Okay, for beam 1, for this span, 2EI. See, it is having 2I. It is having one I and I. Okay, only for this particular AB span of beam, it is having 2I. Substitute that over here, 2I, you will get the matrix. 2, 1, 1, 2 is constant. So for everything we are taking EI common and writing the matrix. Okay, now this is the local stiffness matrix. We will just evaluate the global stiffness matrix. 1, 2, 3, 4, 1, 2, 3, 4. The same as we gave the notes over here. We'll just simply write over this. Next, you know the next step. That is, we will apply the fixed gain conditions. See, for this given beam, it is only fixed gain support D. So here we will just eliminate this row and this column. We will get a 3 by 3 matrix of this. So that would be our new global matrix, global stiffness matrix. Okay. See, we know KD is equals to F. KD is equals to F. See, here we are writing the forces. I told you these are the external forces acting. I will show you. See, as here we have taken rotational degree of freedom. That is, we are defining directions in terms of rotations. We will take the external forces to be these movements that are given in this question. See, these two movements are the external forces acting. Only they are acting in B and C points. Okay, I told you the anti-clockwise would be positive. So this would be negative. 40 would be minus in this direction. Okay. See, that is why minus 40 and plus 60 we got. Okay. Next, we have other forces to add on to this. That is, we should now be adding the fixed gain moments we have calculated in step 1. Okay. As this is a beam, the fixity, like because of this fixity we have assumed, there will be some fixed gain moments to be added to that. Minus 30 plus 30. This is BC is minus 16 plus 16. So we'll just simply write those over here with same notations. If that is negative over there, it is negative. See, I told you MFAB is negative, BA is positive. Okay. Next, BC is negative, CB is positive, CD is negative, but DC is positive. I have wrote all over that values over here. Okay. Simply KD is equals to F. The first one would be the external forces, and second would be the final, the fixed gain moments we have calculated in step 1. See, this is the final KD is equals to F matrix, but here we have to eliminate the fourth row and fourth column over here. The entire this is eliminated. So we'll get a 3 by 3 matrix over here. This is the D matrix and this is F matrix. So after solving, we will be getting D1, D2, D3 values. Okay, this is D1, D2, D3. Next, we are now getting the individual matrix. See, for element 1, F1 and F2 is equals to FR. This is the resultant one. That is, this is again the fixed gen movements, but here we'll take the negative directions. Like see, we'll take, see here we are changing this sign. In fixed gen movements, like we have got minus 30, we'll take plus 30. That is plus 30, we'll take minus 30. Okay, for 1 and 2 elements, this is the force matrix we are adding. Again, it is K matrix, it is D matrix. D1 and D2. As it is F1 and F2, it is D1 and D2. Okay, we'll get the F1 and F2. For element 2, it is F2, F3. Again, we are taking the opposite sign. Remember, for individual one, we'll take the opposite signs of the one we have got before. Okay, this is again element 2. After we solve this, we'll get these forces F2 and F3. Okay, next for element 3, similarly, we'll get the F3 and F4 values. Okay, now we'll just simply draw this, the same beam over here. I told you we have taken the rotations as this. See, F1 we have got 4 into 10 to the power of minus 3, it is almost 0. So we'll just write this. So minus 60.05, that is, it will be clockwise, as it is negative in direction. See, I told you anti-clockwise would be positive. So this would again change. Again, coming to this element, we have 20.067, 7.194. Okay, this 21. So this is again anti-clockwise, this is anti-clockwise. This is again positive. Both are these are positive, so it will be again anti-clockwise. See, for us to just compare it with the previous value or to just have a check, I will tell you the, see, this is 60 clockwise, this is 20 anti-clockwise. So the resultant would be again, see, this is positive, this is negative. Like let us take this is negative or this is positive. See, as it is anti-clockwise, it is negative. As it is clockwise, it is positive. So the resultant of this would be 40, and as it is positive is more, the magnitude of the positive element is more, it would be again positive, that is clockwise direction. Here, as both of these are negative, we'll just simply add and give it a negative rotation. Okay, this is how it is. That is it with this video. Please like, share, comment to my channel. Please subscribe to my channel. Thank you for watching the video. Thanks for watching. Please like, share, comment to my channel. Please subscribe to my channel. Thank you.